Hello, my viewers. I welcome you all to my YouTube channel on PU Form Academy. The PU Form Academy is all about the experience that works in the industry based on the presenter professional experience. Now, I did say that my next presentation will be based on how to set a formulation, and I've done justice to that in my previous lesson. Just look at my lesson. You are going to see the basic principle that you need to understand how PU formulation is being set up. Whether you are using a foaming plant, that is a continuous process method known as conveyor. That is the name commonly assigned to it here in Nigeria, because I don't know where you are watching me from. And we also have batch process, but batch process in Nigeria, people refer it as a box or foam, because the process is being carried out in a box, in a batch by batch process. So they have the same formulation, though there is a conversion factor. In my next presentation, we'll be also looking at those things, because both continuous process formulation and that of batch process formulation is the same formulation. And that is why my kind advice to those in industry, I always tell people, whenever you are setting up a formulation, please carry the formulation in a unit known as pph. Okay, the lesson today is working out density of working out density of 15 per meter cube of or width 15% calcium carbonate. Working out density of 15 kg per meter cube with a 15% calcium carbonate. What does that mean? It means that in this formulation, we are going to make 15 density formulation, but we are going to integrate what? 15 density, but we are going to integrate 15% filler. Okay? Filler here is a substitute. That's another thing you need to pay attention, so that you understand it, how this thing is being carried out or set up. I'm taking an example of the experience that works on 15 density. Just like I said, there is no way you can copy formulation, especially for most of us who are using whether box foam or continuous process, because the machine technology is not the same. So you have to be trained, understand the operational principle of your foaming plant machine, so that you're able to set a formulation that suits that technology. Okay, just like I said, what I'm going to present here is just a guiding principle based on my own professional experience, what it works. That does not mean you have to copy it and paste. When you burn your factory, it's none of my business. Do you understand? Because I don't understand the temperature. And remember, this lesson, what I'm going to present here is under room temperature of your raw material, because factor that affect the rate of chemical reaction, temperature is very, very important. You understand? Now, calcium is a substitute. We have polyol. This polyol is in 100. Remember, this is pph, part by 100, part by 100. Everything is taken to 100. Now, part by 100 is the industrial global convention of scaling up polyol in PU form or formulation. Are we all together? So it's 100. This 100 allow you to precisely, accurately design a PU form formulation that suit that density and that property. Taking into consideration as the example, we are going to look at density of 15. You understand? And mind you, when you are working for a density, to set up a density, not assuming on that your paper setup, you have to carry out what we call a laboratory scale to confirm that density. If it does not, you can either increasing it or reduce it, because while you are taking this to the machine, you have to be certain with a what they call a startup parameters, and it's subject to troubleshooting. While you are troubleshooting, correcting the mistake, we call it on the fly. So understanding the PU form raw material and the chemical reaction or kinetics will help you carry out effective troubleshooting. You understand? Now, this is polyol 100. And remember, you want to integrate 15%. This 15% coming in is that filler will be 15. In this case, the 100 would be reduced to 85. Are we all together? So what it means that you are using 15 parts of filler to substitute it with that of polyol. Now, looking at the two, this one is more expensive than this, but you are able to reduce 15% of this to replace this. That is what it means. Are we all together? Yes. Then you want to make a density of 15. You have in mind that blowing agents, especially water and MC, affects density. They have serious influence on density. In this case, what you need to do is that this calcium does not react chemically. So whatever parameter you are going to choose here, okay, does not affect this young man here. Rather, this is where you are going to work on. In this case, I will now say 85 divided by 15. Okay, what do we have? 85 divided by 15. What do we have? We have 5.66. That's what I have. Then in this case, approximately I will take 5.7. Are we all together? 5.7. In this 5.7 is telling you that your total blowing agent, including water and MC, because it's a density of 15, there is no way we will not need MC. MC is a coolant. The work of MC is that the CO2 that be generated, it is the work of MC to take it from the system to the surrounding in terms of vaporization or process, taking the heat out. So the total blowing agent is going to be 5.7. Now, taking into consideration that 1 kg, this one was determined empirically, experience idea. Now, 1 kg of water equal to 7 kg of methylene chloride. Now, this is the relationship. What is simple tell us that water is a chief blower, whereas MC is the auxiliary blowing agent assisting this water. You know, there are some foam you make, you don't need MC. Okay, it's most especially heavy duty from that, those ones from density from 30 and above, you don't need it, because already the CO2 that you are going to generate, the index that's going to do the foam is automatically safe and hard already. So you don't need to add any artificial hardness to make the foam hard to suit up with what your customer wants. Because in Nigeria, people love hard foam so much. They believe that any foam that does not hard is not a quality foam, but that is incorrect. In my lesson, you are going to see, but for the purpose of selling, you have to do what? Do what your customer wants. Are we all together? I hope I'm making point, and that's what you wanted to hear. Let's proceed. Now, taking into consideration, this is this. So in this case, I'm assuming that in this formulation, I will take water to be 4.4. Now, if you minus 5.5 minus 4.4, let's take it. 4.4 or 5.7 minus 4.4. What we have there is 1.3. It's not 1.3 times 7, because 1 kg equal to, so you want to multiply this times 7. You have MC. My MC will be 9.1 part. Are we all together? Good. Now, this is now my formulation. In this case, you cannot choose TDI. It's the next thing for us to choose TDI. TDI means toluene isocyanide, because you have water. Looking at the chemical safety data sheet, every polyol has what we call hydroxyl value, and let's assuming that the hydroxyl value of this polyol is 44. It's 44. That is, this one is normally stated in the technical data sheet of the supplier of polymeric polyol. The raw material safety data sheet is here for polyol. Now, in this case, we are going to calculate a theoretical TDI index that is suitable for this formulation, so that this formulation will say the function of the index to enable you ascertain that this foam is safe. You don't just assuming for index. So what we do is that TDI is consumed in two ways: the amount that will react with water and the amount that will react with polyol. That is how TDI is being consumed. Go back to my lesson, the previous lesson, when I was talking about forming reaction, how TDI react with water to form CO2 at the gaseous reaction, and how the same TDI react with polyol to form urethane. That is the polymerization reaction and the gaseous reaction. Those are the two basic reaction of foam, but there are other ones, so you need to consult, go to online and check the chemistry of PU foam and the reaction. You have a lot of information are there. Now, in this case, we will have here water is 4.4. 4.4 times 9.67. This is a constant. In my next presentation, I will going to show you how this constant is being gotten. Now, this is the water, but the hydroxide value is 44. 44 times 0.155. So this is the amount that is equivalent to polyol. This is the hydroxide value. This is the water. This is from TDI2. So in this case, we are going to multiply them. So 4.4 times 4.4 times, are we all together? 4.4 times 9.67. I have, for the first one here, I have here 42.55. Now the second one, 44 times 0.155. I have here 6.82. Adding this together plus 42.55. Adding this together will give me 49.37. Okay, approximately 49.4. Okay, so in this case, I'm told that the exactly amount of index to this is 100. What I have here is 100, equivalent to this. Is what we need to choose is 49.4. But in the essence of it, if you choose this one, the foam would be a bit softer. You may have split, you may encounter a problem during the run, and this foam may not meet your customer specification. So for the safety of the foam, this foam is still safe already. So this is where experience is coming in to check at which index am I going to run. Now looking at this, index range is from 100 to 125. You can see, take it, your foam is safe 100 to this. But since I'm using 15 density, let's assuming that I want the foam to not too hard or not too flexible, I will choose an index of 116. Okay, index of 116. So what I will do is what I will do there, what I will do there is to use this value 49.4 times 116 divided by 100. So 49.4 times 1.16. 49.4 times 1.16. This will give me that times, let's say 49.4 times 1.16. This is giving me 57.3. So in this case, this value is no more this. So I'm using this as 57.3 at index of 116. You know, are we all together? At index of 116. Now we now look at tin catalyst. Tin catalyst, I may use this one as 0.17 amine. I may take 0.25 silicon. I might take a 1.05. Now the reason for choosing this one is depend, because all of them has a range. The secret of choosing tin catalyst is that as you are increasing your methylene chloride, because it attacks stenols, you have to shoot this one up, I mean the stenols. Then the amine is that because it is a low density, the blowing agent is a bit higher, so the foam tend to rise quick. So in that case, some of the amine increasing the rising, so you don't need to pour more amine. But the function of amine, apart from influencing other chemical, can also make it dry faster and cure. So that is why in this 1, 2, 3, you have to carry out what we call box foam. Box foam. We have to carry out a test known as box foam. Box foam. That is at the laboratory scale. At the laboratory scale. So in the laboratory scale, it will enable you to check when do you need to reduce this or decrease this, reduce this, increase this or reduce this, increase this or reduce this, because silicon there is a stabilizer. Okay, when the foam rise at a full rise, the F figure will be generated, so the foam will not tend to make any mistake of collapsing because of the presence of silicon. Okay, one factor that need is also mixing. Now in this case, you can easily formulate, design your density. Now wherever you are, copy this, carry out a box foam. You are going to have 16 density. If you don't have 16 density, then come and ask me a question that you try it wasn't a 15 density. That is to say there's a mistake. The reason of increment is because of this. If I remove this, it will give me this, but I've added this, it should the density to this. That is how filler is being integrated. So filler is integrated in polyol in substitution, not in addition. You cannot say 115. That is not the concept. The concept is 100 minus 15 because it is a substitute. Okay, it's a locally sourced raw material that is used in substitution of polyol in part by 100. For those of you that are using a continuous process machine, for you to convert this to a continuous process machine, that the conveyor to run, is very, very simple. Okay, how is it simple? What you need to do, you choose your output. Let's assuming if it's a low output machine, I can decide to say, okay, for polyol I'm going to use the 110. So what you do is, for example, you use 110 kg per minute. Okay, so in this case, that is including filler and this. What you need to do, you just say 110 divided by 100. So that give you 1.1. So 1.1 times 85, the polyol you are going to set polyol as this per this kg per minute. You see? Now your calcium, remember you have 1, you are choosing one thing, 1.1 times 15. So polyol will give you 16.5 kg per minute. When you add this to this, it will go back to 1. So you use the constant of this to multiply all of this and set it. Okay, let me do the water. 4.4 times 1.1. Water will give you 4.84 kg per minute. Then the MC, you have 1.1 times 9.1. 9.1 times 1.1. MC will give you 10.01 kg per minute because that is a unit. Now your TDI will give you 57.3 times 1.1. TDI will give you 63.03 kg per minute. Then your steno will give you 1.1 times 0.1. Steno will give you 0.19 kg per minute. Then for amine will give you 0.25 times 1.1. Amine will give you 0.28 kg per minute. Then silicon will give you 1.05 times 1.1 will give you 1.2 kg per minute. So that is how to carry out the conversion. You choose your output, you that polyol by 100 because this is respect to 100. So when you set up this, all this formulation, just like I said, don't copy it. It's just a guiding principle. What will guide you to arrive at the best result. For those of you in box form, I will also show you how to convert this formulation to box form or process. You still have the same density. That is why I said it is better to carry out formulation in pph because this is the industrial standard to enable you accurately design this so that the conversion process will be easy. I hope you have learned a lot. So just like I said, more are coming. Next one we will look at the water-blown formulation and the extremely low density. Several one. You are going to learn a lot. So the only way, if you are industry, the entrepreneur, the captain of industry, the engineers, even those that are in the system, the farmers, the incoming farmer, please take a look at this, study it, understand the basic principle, continue to like my page on your notification bell so that when I release a new update, you'll be notified. The subscription is free. Is that not interesting? Bye. Thank you, my viewers.